Hello students, and welcome to the review session on solving equations algebraically and graphically. And we are dealing mostly with quadratics and absolute value equations in this section. And we'll start out by solving a quadratic. Now, the methods that we're using here, it will apply to other equations as well, but we're going to primarily use quadratics and absolute values as our example. So the first one here, when we're solving for x, okay, and it says x squared minus x equals 20. So the first thing that I'm going to do here is subtract 20 from both sides, and that will give me x squared minus x minus 20 equals 0. And I will try factoring this if it's possible at all, and I believe it is, okay? And just to review, the reason that I have to factor, or I cannot just solve this some other method, is because there is a x squared here and an x. So I can't really multiply everything by x, or I can't really divide everything by x, because I have two different powers of x's here. So I'm going to try to factor this. And I think this factors out to x minus 5 times x plus 4 equals 0. Okay. And again, I'm not going to go too deeply into factoring. If you need some help with it, please see your teacher or see one of the Algebra 1 videos that will go into factoring in much greater depth, or some of the Algebra 2 videos that will also go into quite a bit of depth into factoring. But this is a fairly straightforward example. And when we have in this case x minus 5 times x plus 4, a lot of students will just write that x equals 5, x equals negative 4, which is not technically wrong, but we want to develop the concepts a little bit better. So one of the things we know, this is called the zero product property, and I write it in the margin here. It says that if a times b equals 0, then there's two answers to this problem. A could be equal to 0, and b could be equal to 0, and both are perfectly legitimate and good answers, because if a is 0, it doesn't matter what b is. The product will be 0. If b is 0, it does not matter what a is. The product will also be 0. So here we have a product, but it's, instead of a singular variable, we have an expression, but the same thing works. So we can say that x minus 5 equals 0, and x plus 4 equals 0. And we can just solve these little equations, and that gives us x equals 5 and x equals negative 4. And both of these are answers of the problem, and I'll leave it to you to check that if we were to substitute in here, we would in fact get 0. Whether we use 5 to substitute, or we use negative 4 to substitute, this equation will hold true. Okay? So that's an example of using factoring. So I have another example here, and this one doesn't involve factoring. We have an equation 3x minus 1 quantity squared equals 25. And a lot of students at this point will just multiply this out and go from there, but that often leads you to more work. When we have an expression that is neatly captured like this with a square, that is a beautiful thing, because what we can do here is just to take the square root of both sides, and the square will cancel each other or eliminate each other, and we get 3x minus 1 equals the square root of 25 is 5. Add 1 to both sides, and we get 6. Divide both sides by 3, we get x equals 2. And at this point, this seems pretty straightforward, but we actually missed a step. One of the things that we forgot is that square root of 25 actually has two solutions. Okay, so the square root of 25 is equal to 5, positive 5, and the square root of 25 is also equal to negative 5. Okay. And to see why that is, we know that 5 squared equals 25, and we also know that negative 5 squared is also 25. So when we take the square root of 25, there's actually two solutions. So we have to solve this problem twice. Once for 3x minus 1 equals 5, and the second time 3x minus 1 equals negative 5. And from here, add 1 to both sides, you get 3x equals negative 4, then divide both sides by 3, and you get negative 4/3 as your other answer. And actually both of these values are solutions to that equation. And I'm going to make a note here. This is called extracting square roots. Okay? Because that's what we've really done here, is that we've got a beautiful perfect square on the left side. We take the square root of that, and that gives us a simple expression. On the right side, we're very lucky that we have 25 here, which is also a perfect square, and we can take the square root of that. And the problem becomes fairly straightforward. Now, this too is a quadratic. If you were to graph this, if you were to set the left side here equals to y and graph it on your graphing calculator, you will see a quadratic, but it's written in a different way, and it's written in a very simple way for us to solve. Okay, so this is a really good case called extracting square roots. And we're going to explore this concept a little bit more here before we move on to our next example. Okay, so we're going to do a couple of examples here of just what I call just filling in the blanks. So x plus 3 is quantity squared. And you might want to hit pause and see how much you remember this from your previous math classes. But this is x plus 3 times x plus 3. Okay? It is not x squared plus 9. I'm not even going to write this down here because I don't want you to mix it up. But this expression is not x squared plus 9. My heart dies a little bit every time a student writes x squared plus 9 to this type of problem. And we can FOIL, so I'm going to write it under, actually I'll write it over here. This is x squared plus 3x plus 3x plus 9, and that simplifies to x squared plus 6x plus 9, okay? And that's our final answer for this problem. So it's a fairly straightforward problem where we're filling in one of the blanks. And we're dealing primarily with cases where you have a perfect square here. So what we're going to try to do here is do some examples and try to relate these types of examples to these type of examples before we move on to the next example and concepts. So I've got a slightly more complicated example. This time we have two blanks to fill. And x plus something, quantity squared, is equal to x squared plus 8 plus 16. Okay? Now, to do this problem, it's a little bit tricky, but we can look back at our previous problem for a little bit of a clue. Here, when we squared this, we have this expression multiplied by itself. And if you notice that this term here is used twice, so we get 3x and 3x, which then turns into 6x. Okay? In this case, it's not 6x, it's 8x, which leads me to believe that this has to be a 4. Have a good night, Christina. So if this is a 4, now we can multiply and expand it. This is really equal. I'm going to write it down here. X plus 4 times x plus 4, which is equal to x squared plus 4x plus 4x plus 16. So that means this here has to be 16. Okay? So these two terms combine to give you the 8x, and this term squared gives you the 16. Okay? So there's a bit of a pattern here that will emerge, and let's do one more example like this with nice round integers. So we have one more example here where we have x plus something, quantity squared, excuse me, I forgot the squared there, equals x squared plus 14x plus something else. Well, following the same example what we did before, this middle term here is really key. If you notice, the number that goes into the quantity squared is just 1/2 of the middle term. It was 8 up here, so it's 4. It was 6 up here, so it's 3. It's 14 here, so this has to be 7. And the term in the end here is just the quantity, the number in the quantity squared. So it was 3 here, so we square that, that's 9. It was 4 here, so we square that, and you get 16. It's 7 here, so when you square that, you're going to get 49. And just to be sure, just so that we can check, you get, if we were to expand this, x plus 7 times x plus 7 equals x squared plus 7x plus 7x plus 49. Okay, so the first, inner, outer, and last terms will give us x squared plus 7x plus 7x plus 49. These two terms combine to give us the 14x, and 49 comes from the last two terms here being multiplied. Okay, so we have 3 examples here where we have to fill in the blanks, and if you notice that when you have an expression like this, sometimes it can be shrunken down or factored back into a perfect square. Okay, and again, this type of expression is very, very useful because if you have this expression inside of an equation, it is possible for you to do this type of problem and solve it fairly quickly. So we'll do one more example here, but this time it's going to get fairly tricky. Okay, so here I have a fill in the blank problem, part D up here, and it says x plus blank quantity squared is equal to x squared plus bx plus blank. Okay, so this time I'm kind of throwing the monkey wrench into the process here by introducing a variable. Instead of having a number here that you can divide and square and all that stuff, I've just given you a variable. But note that the same process applies. Nothing much has changed from here. Here in example B, we divided by 2 to get this number, and then we squared this to get the last term. Here we took 14 divided by 2 to get 7. We squared that and we got 49. So in this case, we can do the exact same thing. We can take B and divide it by 2. That's the value that's going to go in here. And we can square that, B over 2 quantity squared, to get the last term. Okay. And this is, it looks complicated, but this is actually a very helpful example because it says that this process will work no matter what number we use. Just take B, whatever this number is, divided by 2, and that's what's going to go in this quantity. If you square this, you're going to get this term out here. Okay, so let's keep this in mind as we proceed to the next example. Okay, so we have an example here. X squared equals 4 minus 6x, and we want to solve for the variable. So we'll start by proceeding kind of like we did in example 1. Let's just move everything to one side. So I move negative 6x to this side, I get positive 6x. Move 4 over, I get negative 4. Set that equal to 0. And let's try to factor. You're looking for two numbers that multiply to give you negative 4 and add to give you positive 6. And you can look through all of the combinations. 4 and negative 1, negative 4 and 1, 2 and negative 2. And it turns out none of these combinations, these are the numbers that multiply to give you negative 4, but none of them will give you a sum of positive 6. So sadly, factoring does not work in this case. Okay? So we have to try a different method here. And we are going to use some of the fill-in-the-blank examples that we did earlier to help us. So the first thing that I'm going to do is move the 4 back to the right side. And I'm going to purposely leave a space here between the 6x and the equal sign. And this effectively becomes a fill-in-the-blank type of problem. I need to add something in here on the left side that will allow me to turn it into a perfect square, into a problem where I can extract the square root. So in the next, so this is step 1, step 2, step 3. In step 4, I want to be able to get this type of expression. So what number should I add in here in order for me to factor it down into a perfect square like that? Well, let's look back at some of the examples we did before. Notice we take this middle number, and this middle number is really the key. Take the middle number, divide it by 2, and that'll give you the number that goes inside of the quantity squared expression. So we take 6 divided by 2, and that will give us 3, and this goes in there. And if we take 3 squared, if you take this number in here, square it, it will give you the constant term. Same as here, we took 14 divided by 2 to get 7. Now if we take 7 squared, it gives us 49. So we take 3 squared, it should give us 9 up here. Okay, so if we add 9 up here in step 3, it will allow us to factor it into a perfect square in the next step. Now, it's okay to add 9 to this left side of the equation. That's the beauty of an equation, as long as we add it to the right side as well. And now we can just proceed with the example. The right side gives us 13. And if you notice here, if you compare this problem to the problem in example 2, they're very similar. You have a beautiful perfect square on the left side. Here you have a less beautiful non-perfect square, but the problem still works. We can still take the square root of both sides. Take the square root of both sides. We get x plus 3 equals plus or minus the square root of 13. Keep in mind that there's two solutions to this: positive square root of 13 and negative square root of 13. And then you can subtract 3 from both sides, and you get x equals negative 3 plus or minus the square root of 13. And that will be your answer. This is a perfect answer. It is simplified as far as it can possibly be. Now, sometimes if you're asked to round, you might have to type this into a calculator and get two different answers. Negative 3 plus square root of 13. Do it again, negative 3 minus square root of 13. But this is the best, most simplified exact answer. And this whole process here is called completing the square. Okay. And one of the things that is really nice about completing the square is that I'm going to say that I'm going to write this note on the side here: completing the square. Completing the square always works if the coefficient of x is 1. Okay, so factoring only works sometimes, only when you can actually factor it. Completing the square will always work, but this number in front here of x squared, the coefficient of x squared, I'm sorry, has to be 1. If this was a 5 or a 9 or something else, you can't really do completing the square. Okay, so you have to get rid of that coefficient first. When you have a 1 up here, completing the square is a great method. It'll lead you to the perfect, most simplified, exact answer. Alright, so moving on here, we have another example. 2x squared minus 1 equals 2 times quantity 3x plus 2, and we need to solve for x. Now again, we have different powers of x squared and 3x plus 2. We can't really take the square root yet. I mean, we could, but it won't really help anything. So I'm going to multiply everything out on the right side. 2x squared minus 1. On the right side, I get 6x plus 4. Then move everything to the left side. So I get 2x squared minus 6x. Negative 1 minus 4 is negative 5 equals 0. And here I'm going to try my best to somehow simplify this or to factor it, but I don't think this can be factored. We can give it a shot, but I think it's going to be very difficult. It's probably impossible, since you're not going to have a nice number there. So we're going to try completing the square. Now, we'll start by taking 2x squared, subtracting 6x, and then just moving 5 to the other side. Okay. Now remember what I told you before, that for completing the square, this coefficient must be 1. Okay. If the coefficient for x squared is not 1, this simply doesn't work. So our solution to that is just to take this coefficient, whatever it is, and divide everything by it. So I'm going to divide everything by 2. And now I get x squared minus 3x equals 5 halves. Okay? And it's perfectly allowed and it's perfectly quote-unquote legal to do this, to divide everything by 2, as long as we divide everything, every single term on both sides by 2. Okay, that's a perfectly valid algebraic operation. And so now we have something that we can complete the square with. And so we want to have something here to fill in the blank. And then we want to be able to do x squared. Because this is a subtraction sign, it's subtracting 3. Sorry, it's going to be x minus something quantity squared equals whatever it is on the right side. Okay. So if you go back to the other examples, the main thing, the most important thing, is that we have the middle term here. And if you recall, whatever the middle term is, half of that goes inside the square root. And the middle term here is negative 3, hence the negative. We're going to have negative 3 over 2 as the constant. Let me write that a little bit bigger. It's going to be negative 3 over 2 as the number that goes inside the quantity squared. And this number here is just this quantity squared. So it plus or minus here doesn't really matter much because we're squaring it. So we're going to have 3 over 2 quantity squared. Now if you notice here, because the coefficient was 2, things are a little bit messier, but everything still works. Since we added this term here on the left side, we have to do the same thing to the right side. And if you just do this operation, either I'll do this on the side here, 5 over 2 plus 3 over 2 quantity squared is really equal to 5 over 2 plus 9 over 4. That's equal to 10 over 4 plus 9 over 4, and that's 19 over 4. Okay, so this expression here, this is just a number that we can calculate, comes out to 19 over 4. Okay. Then we can take the square root of both sides, and that will give us x minus 3 halves equals plus or minus the square root of 19 over 4. Now I'm going to leave the left side alone a little bit and then just try to simplify the right side here. If you remember the rules for square roots of a fraction, you can really do square root of 19 over square root of 4. Okay. If you don't believe me, try this on a calculator. Square root of 19 over 4 is the same thing as square root of 19 over the square root of 4. Remember the plus or minus. X minus 3 halves equals, and in the denominator, the square root of 4 is just 2. Okay. And then we can add 3 halves to both sides. So x equals 3 over 2 plus or minus the square root of 19 over 2. And since both of these have the same denominator, we can combine them together to give us 3 plus or minus the square root of 19 over 2. Okay, and this right here is our final answer. It is the simplest answer that we can have. The square root of 19 cannot be reduced any further. But the main idea that I want you to get from this is this key step right here in blue and in red, is that if you want to complete the square, the coefficient of x has to be 1. So in order to make that work, just divide everything by this coefficient, and you get a coefficient of 1. things are a little bit messier because we have fractions and we have the squares of a fraction, but the same rules apply. We have to do a little bit of side work here in order to, complete this operation. So we've solved a bunch of problems a bunch of different ways, and the real question, or one of the questions we get to is that, is there a formula for this? And of course, this is the quadratic formula. It's opposite of b plus or minus square root of b squared minus 4ac all over 2a. Okay, and the way I remember this is through the song. Opposite of b plus or minus square root plus or minus square root b squared minus 4ac, b squared minus 4ac all over 2a, all over 2a. So that's a catchy little tune that'll help you memorize this. But the quadratic formula really comes from completing the square. Okay? And if you want to see the proof for this, there's a bonus video on this material. You can see the proof for how this comes about. But the main thing is that the quadratic formula and completing the square will always work, and because they really are equivalent. So let's take a look at example 5, which is revisiting example 4, where we have this equation 2x squared minus 6x minus 5 equals 0. So in this case, using the quadratic formula form right here, we know that this here is a is equal to 2, b is equal to negative 6. You gotta be, let me write my b's and my 6's neatly here. Okay, that's a b and that's a negative 6, and then c is negative 5. So we have these three values. Now we can just substitute them into the formula. So I know that x is equal to the opposite of b, which is in this case 6, plus or minus the square root b squared negative 6 quantity squared minus 4 times a, which is 2, times c, which is negative 5. All of that over 2 times a, which is also 2. And then now we just have to simplify. X equals 6 plus or minus square root of, that's 36, 4, negative 4 times 2 times negative 5. That is 8 and 5, so that's 40. All of that over 4. So x is equal to 6 plus or minus the square root of 76, all of it over 4. And we can simplify the square root of 76. This is 6 plus or minus the square root of 4 times the square root of 19, all of it over 4. I might run out of space here, but this is 6 plus or minus 2 times the square root of 19 over 4. Okay. The 6, 2, and 4, we can factor out a 2 in that case. Now let me write my answer to the side here. You should write this on the main part of your paper. This is really equal to 3 plus or minus the square root of 19, all of it over 2. So you can compare this answer to the example you got in example 4, and it's the same thing. And the reason for that is that the quadratic formula and completing the square is really the exact same method. Okay, so here we have it. These are these 5 examples capture how do we solve a quadratic equation algebraically. We've seen it with factoring, which works sometimes. We've seen it with completing the square, which works all of the time, but it's a little bit messier with when you have an a coefficient and when you have a coefficient here in the front. And you've seen it here with the quadratic formula where you have to substitute, and it's just all how do you handle the arithmetic and the square roots gracefully. Okay, so those are the 3 methods that we have at our disposal algebraically. If you look at the next video, we'll talk about how to solve these equations graphically.